Hi, my name is Chris and I'm a developer with Kii Cloud, and this is the second part in my video series for creating SpriteKit games on iOS. And if you missed it, the very first part of our video series was a brief introduction to creating a SpriteKit game within Xcode using the template that they provide there in Xcode. And then we started to implement a couple of physics bodies into our scene and started to play around with the physics engine that Xcode sits on, or SpriteKit sits on. In this part of the tutorial, we're actually going to start building out the game board and getting our scene ready for gameplay. So if you missed the very first part of the video series, I highly suggest going back. There's a link provided below, but if you're all caught up, then let's go ahead and dive right into the code. So just to remind you where we left off, we'll do a build and run here, and we have our block falling down onto the floor. Very simple interaction with gravity and two physics bodies. Okay, so what we want to do is create a grid of these blocks. Now to do that, we're just going to need to create a number of different blocks. Here we're just creating a single block. So we're going to extract this into its own method. And to do that, and we're just going to create a method called createBlock, and copy and paste this code right in. And that'll create a one-off block and add it to our scene. Now, of course, we need to call this, so we'll call it here at the end of our initialization method. And if we build and run, we should get the same result. Okay, easy enough. Now, if we're going to create multiple blocks in a single scene, we want to specify their position and their size to make it more dynamic. So we'll get this method ready for that. And we're just taking in the block size and the block position into this method. So now we'll go ahead and make this dynamic using the parameters in our method. And we're going to go ahead and check by building and running one more time, but we can't because we haven't updated this. So we just need to add those parameters into this guy here. So you can see our method signature pops up automatically. And we'll go ahead and give it a size of 100 and a position of 160 and 480. And those are the same values we were using before. We're just making everything a little more flexible. So now, again, we're getting the same block falling. Okay, so now we'll get into the good stuff. First of all, we want to define how many columns we want our grid to have. And in this case, we're just going to go ahead and do 6. And we want to create a block for each column that's provided. So we'll create a simple for loop. And within that loop, we'll add our create block statement. So now we're creating 6 different blocks, but right now they're all in the same position. So what happens when we build and run and all the blocks are in the same position? Well, it's going to look something like that, and that's not quite what we're going for. Well, not quite what we're going for. So what we need to do is make this x of the position, the x coordinate, we want to make that dynamic based on the column that it's in. But first, we're going to create the dimension dynamically based on the columns as well. So we want the columns to fill up the entire screen. So we'll make the width equal to the screen size divided by the number of columns. And in code, that looks something like this. And then we're going to create our x coordinate. And we'll use the call incrementer here, just so it's a little more readable. So what this x position is doing is just lining up the blocks horizontally so they're all sitting next to each other on the screen. And we'll go ahead and we'll make our x position dynamic here. And we also want to make our dimensions dynamic as well. And we're using dimension twice here as the width and the height because we want to use squares, not different shape rectangles. So if we build and run, we should see a line of blocks falling down. And there we are. Notice not a whole lot of stuff happened. We can't even tell that they're individual blocks. So what we're going to do is update the restitution of our floor, and we'll clear that and leave it at default. So hopefully we get a little bounce this time, just so we can see a little something happening. There we go. Now we want to make the blocks different colors, so we can differentiate between one or more blocks. So we're going to update our create block, and we're going to add a color parameter as well. And we'll use that color here. We need to make sure that we update this method down here where we're actually calling the create block. So we want to add a color here, but we want the color to be randomized. So let's create a quick array of colors. Now that we have an array of 3 different colors, we want to pick one of these colors to be used for this block that's being created. So we'll start by creating an index to select one of these colors out of the array. And we'll use the arc4random method and a modulus to keep it within the length of our array. So what this is doing, this color index, is selecting a number 0 to 2 inclusive, and it's going to use that index to select one of these colors at random. So we go ahead and append the color here at the end, and we'll go colors, object at index, and we'll use our random color index here. We'll make this a little prettier and build and run, and hopefully we get various color blocks. And we do. Now let's go ahead and change the color of our floor as well, and we'll just make that a clear color. Well, let's make it black, just so we don't get our blocks mixed up. And now the blocks are sitting there on the floor. Now the next thing we want to do is create stacks of these. So we want to create different rows. So similarly, we'll add a nice definition up here. And we'll make 7 rows this time. And using these kind of defines is very, very helpful because you can tweak some major parameters within your game just within the top of the file. So it makes it easy. You don't have to sift through code and make sure you're not missing anything. Just use constants like this. So on top of making columns, we want to make some rows as well. And we'll create another for loop and put our column in here. So this is kind of creating a 2-dimensional stack of blocks. And what we'll see here if we build and run is we're creating a number of different blocks, a lot more blocks, and they're kind of bouncing all around, being messy, and that's because we're not specifying different positions. So here we're specifying different x positions, but not different y positions. So if you can imagine, all of these physics bodies are being stacked at the same y position, however many rows there are. So we have 7 rows, so there's 7 blocks being stacked on top of each other. Now when the scene is created, this stack of blocks will just kind of go everywhere, and it's a mess. So we need to specify a y position so they all are stacked nicely on top of each other, and they all fall down a little more cleanly. So we'll do that just like we created the x position in this spot here. And we'll have a base height of 480. And we'll stack them up based on their height, depending on which row that they're in. And we'll make our y position dynamic as well. And go ahead and build and run. And now things fall pretty nicely, actually. There's still things tipping over there on the side, but they're all stacked up, and we're moving in the right direction. So if you notice when we build and run this, some of the blocks are kind of falling off to the side and different forces are being applied on them. What we want to do is turn off that angular rotation so the blocks don't turn left or right or around an axis. They just drop straight down and are only affected by gravity and the blocks above and below them. So SpriteKit and the physics engine within actually make this pretty easy, and it's just a single attribute. And we can turn off angular rotation just with a Boolean value. So we'll go ahead and do that now. Up when we're creating our blocks, we'll just go block.physicsBody and angular, let's see, allows rotation equals false. And the default is true. So now when we build and run, we should be able to see that the blocks don't turn around that axis. They just jump up and down. And that's exactly the kind of thing that we're looking for, just like this. Now notice our node count here at the bottom. So remember, we've got a floor, and then we've got 6 columns and 7 rows. So we've got 42 blocks and 1 floor. So that accounts for our 43 nodes. And also notice that we started with 60 frames per second when there were no nodes on the screen. But now we slowed down to 30. So as you're developing your game, this is a very useful way to see how fast and how efficiently the game is running. Once this frames per second drops too low, then your game starts to get choppy. So it's something that you want to keep an eye on throughout your development process. But 30 frames per second on the simulator is actually not so bad, so we're not worried about this at all yet. Another tweak that we want to make before we wrap this up is altering the physics body just a little bit. So throughout our testing, we noticed that sometimes these blocks would get hung up on one another. So we want to make the physics body slightly smaller than the box that you see on the screen. So we'll do that by altering the block size here. And another final tweak that we're going to make is here in the update method. Now, as it says here in Apple's pre-generated comment, the update method is called before every frame is rendered. So this is a great spot to see what's happening in your scene and make any adjustments that are needed before the frame is drawn to the user. But be very careful with this, because if you try to do anything that's too intense within this method, you'll see your frame rates drop drastically, and you can see performance really taking a hit. But what we're going to do is just iterate through all the children and make sure that they're all staying within their column. And we want to make sure that their x coordinates are exact so they don't start bouncing into each other and bouncing off one another. We just want them to drop straight up and down. So to do that, we're going to iterate through all of our nodes, and we'll use a different type of for loop here. We're going to iterate through every node on the screen, or every node in the scene rather. And for each of these nodes, we're going to round the position, particularly the x position is what we're worried about. So we'll set the node's position and do a rounding method on each of the coordinates within. And we're all set. If we build and run, we shouldn't see much of a difference here. Now there's one little flaw here in our game board, and there's a black line running right through the middle of our board. So there might be something off with our dimensioning. So let's go ahead and try changing the size of our block to something a little more rounded and integer-like. Change that to 320 and see what happens. Okay. So now all the blocks are nice and flush together, and the game board is looking pretty good. Now that's going to wrap up this part of the tutorial. So we created our game board, and we've worked with the physics engine, and we're getting ready to actually start interacting with the user and making some game-like qualities within this app. So in the next iteration, in the next part of this tutorial, that's exactly what we'll get into. Now, as I've mentioned a few times, this project is open source. So if you check out these links here, you can go and download all the source code that you need to build and run this project. And if you don't want to have to worry about dealing with the whole finished, more advanced game than what you see here, you can check out the Git tag. We tagged the release, and the tag is going to be tutorial-2. So what you see on the screen here, you can download a snapshot of the code where we were when we finished this specific tutorial. So go ahead and check all that stuff out, and hopefully we'll see you in the next part of our video series, where, as I mentioned, we'll actually start interacting with these blocks and making this more of a game. So we hope you enjoy, and happy coding.